Welcome to the video on definite integrals and area. So first we'll learn how to solve a definite integral by hand. To find the solution of a definite integral, you'll take the integral and then evaluate it at the final point, and then subtract the integral evaluated at the initial point. So if you had an integral from some value a to b, it would be something like this, and you'd have your initial value a and your final value b. So you would find the area under the curve by taking the integral of that. So your integral of g prime of x is g of x, and you would evaluate it at your final point minus your initial. So you would do the total area to the final point and then subtract your area to the initial point so that you can get the area between them. So some integrals cannot be solved without technology, so you will have to use calculators for some, but if they give you it on the no calculator portion, you should be able to solve it by hand. So next we'll learn how to calculate the area. To find the area between a curve and the x-axis, then if you did the integral from, say, 0 all the way to 7, it would take this area and subtract the area down here. But we want to find the total area, so you'll find when f of x is greater than 0, so that would be from 0 to 4, for example. And then you'll split your interval into intervals where f of x is positive, and then separate intervals where f of x is negative. So you would have the integral from 0 to 4 of f of x dx plus the integral from 4 to 7 of f of x dx. So this would give you some area minus some other area. So you'd take the absolute value of each of these and add them together for the total area. To find the area between two curves, f of x and g of x, you would find when your functions are equal to each other. So you could have a function like this and then a quadratic function. So you want to find these intersection points, and then you'll take your integral from your first intersection point to your second intersection point of your function on top minus your function that's on the bottom. So in this case, our function f of x is on top of the section where they intersect, and g of x is on the bottom. So your integral would be the integral from your first intersection to your second intersection, and these are your x values, of f of x minus g of x dx. So that's how you would calculate your areas. So here we have our first IB practice question. It's no calculator. It says find the area of the enclosed space between f of x equals x squared minus 2x plus 1 and g of x equals negative 3x squared plus 3. So we can start by drawing a picture of our functions. So our f of x is this. So if x is 0, y is 1. Our function is going to be concave up like this because it's positive in front of our x squared. And then if you remember to find your line of symmetry with quadratics, it's going to be negative b over 2a. So that's going to be negative negative 2, so 2 over 2 times 1, which equals 1. So when x is 1, that'll be our line of symmetry. So if we plug in 1 for x, we get 1 squared minus 2 times 1 plus 1. So that equals 1 minus 2 plus 1, which is 0. So f of 1 equals 0. And then that's our line of symmetry, so we'll have another point at 2, 1. So our function's going to look something like that for f of x. And we'll label it. Then for g of x, it equals negative 3x squared plus 3. So if we plug in 0, our g of 0 equals 3. It's negative, so it's going to be concave down. We'll have a maximum. And to find our line of symmetry, we'll use our x equals negative b over 2a. B is 0 because there's no x value, so our line of symmetry is when x is 0. So if we wanted to find another point, we could plug in g of 1, which is negative 3 times 1 squared plus 3. So negative 3 plus 3 is 0. So g of 1 is 0. So at negative 1, it'll also equal 0 because our line of symmetry was x equals 0. So our g of x will look something like this. So we want to find when they're equal to each other. So we'll set f of x equal to g of x. So we have x squared minus 2x plus 1 equals negative 3x squared plus 3. We'll add 3x squared to both sides. So we have 4x squared minus 2x plus 1 equals 3. Then we'll subtract 3 so we can set it equal to 0. So 4x squared minus 2x minus 2 equals 0. We can factor out a 2, so we have 2 times 2x squared minus x minus 1 equals 0. Then we'll see if we can factor this. We can use our box method, where we'll put our ax squared in the top left corner, so 2x squared, and then our constant in the bottom right corner. So we need to find what multiplies to negative 2 and adds to our b value, which is negative 1. So that's going to be negative 2 times positive 1. So we'll do negative 2x and just x here. Then we can pull out our greatest common factors to get x minus 1 and 2x plus 1. So we have 2 times 2x plus 1 times x minus 1 equals 0. So we can find when this is true by setting each of these equal to 0. So we have 2x plus 1 equals 0 and x minus 1 equals 0. We'll subtract 1 from each side to get 2x equals negative 1, and then divide by 2 to get that x equals negative 1/2. And for the other one, we'll add 1 to both sides to get that x equals 1. So our intersections are at negative 1/2 and 1. So we're going to take our integral from negative 1/2 to 1, and then we need to figure out which function's on the top. So we label our g of x as well. So g of x is going to be the function on top, and f of x is going to be the function on bottom when we look for our area here. So our integral is going to be of g of x minus f of x. So this would be our integral from negative 1/2 to 1 of negative 3x squared minus x squared, so negative 4x squared. Then we have negative 2x, so plus 2x, and then 3 minus 1, so plus 2, dx. So the integral of that would be negative 4/3 x cubed plus x squared plus 2x evaluated from negative 1/2 to 1. So we'll start by plugging in 1, and we'll go all the way over here to do that. So we have negative 4/3 times 1 cubed plus 1 squared plus 2 times 1. And then we have all of that minus our function with negative 1/2 plugged in. So it'd be negative 4/3 times negative 1/2 cubed plus negative 1/2 squared plus 2 times negative 1/2. So our first part is negative 4/3 times 1 cubed, so that's negative 4/3, plus 1 squared, so plus 1, plus 2 times 1, so we have plus 2. Then we have minus negative 4/3 times negative 1/2 cubed. So negative 1/2 cubed is negative 1/8. And when we multiply that by negative 4/3, we can simplify that to be 1/6. Then we have plus negative 1/2 squared, which becomes positive 1/4. And then plus 2 times negative 1/2 is negative 1. So then we have a common denominator of 3 for our first part. So we have negative 4/3 plus 3. So it's going to be negative 4/3 plus 9/3 minus, we'll have a common denominator of 12 for our second part. So we'll have 2/12 plus 3/12 minus 12/12. So this equals 5/3 minus a negative 7/12. So plus 7/12. We can do a common denominator of 12 by multiplying them by 4. So we have 20/12 plus 7/12. So this is 27/12. So the area is 27/12 units squared. Now we have our second IB practice question. It says find the area between f of x equals x cubed minus 21x squared plus 122x minus 168 and the x-axis where 0 is less than or equal to x is less than or equal to 10. So what we care about most is going to be the zeros within our interval. So we could try x minus 1 because this would mean we have a 0 when x equals 1. So if we have a negative 1 here for synthetic division, we'll put a 1 on the outside. And then we'll have our coefficients of 1, negative 21, 122, and negative 168. We'll bring down the 1. 1 times 1 is 1. So then we have negative 20. Negative 20 times 1 is negative 20. So we have positive 102. 102 times 1 is 102. Negative 168 plus 102 is negative 66. So x minus 1 is not a factor. So now we'll try x minus 2 to see if we have a 0 when x equals 2. So we'll put a 2 here. Our 1, negative 21, 122, and negative 168. Bring down the 1. 1 times 2 is 2. Negative 21 plus 2 is negative 19. Negative 19 times 2 is negative 38. 122 minus 38 is 84. And 84 times 2 is 168, which gives us 0. And since the remainder would be 0, that means that x minus 2 is a factor. So it would be x minus 2 times, we had a third degree, so we'll go down to second degree. So it would be x squared minus 19x plus 84. So now we want to factor this trinomial. We can use our box method with our x squared here and our constant here. So we need something that multiplies to 84 and adds to our b value, which is negative 19. So that's going to be a negative 7 times a negative 12, which gives us a positive 84, and negative 7 minus 12 gives us negative 19. So we'll have negative 7x and negative 12x. Then we'll pull out our greatest common factors. So we have x, we have negative 12, x, and negative 7. So our f of x equals x minus 2, x minus 7, x minus 12. So this means we have zeros at x equals 2, 7, and 12. So in a cubic function, because it's positive, it's going to start down and end up. So it'll start down. It'll go up through 2, come back down at 7, and then go back up at 12. So our function will look kind of like this, and our interval is from 0 to 10. So it would be from here to here. So we need to find this area, and this area. So we'll find them each separately. So we'll have our integral from 0 to 2 of f of x, which is x cubed minus 21x squared plus 122x minus 168 dx. And we'll do the absolute value of that plus the absolute value of the integral from 2 to 7 of our function, x cubed minus 21x squared plus 122x minus 168 dx, plus the last portion, which would be from 7 to 10. So it'll be the absolute value of the integral from 7 to 10 of x cubed minus 21x squared plus 122x minus 168 dx. So our integral would be 1/4 x to the 4th minus 7x cubed plus 61x squared minus 168x evaluated from 0 to 2, and the absolute value of that plus the absolute value of the second part. So it's going to be the same integral, 1/4 x to the 4th minus 7x cubed plus 61x squared minus 168x evaluated from 2 to 7 plus the absolute value of 1/4 x to the 4th minus 7x cubed plus 61x squared minus 168x evaluated from 7 to 10, the absolute value of that. So we can evaluate them one at a time. So we'll start by evaluating this. So we have 1/4 2 to the 4th minus 7 times 2 cubed plus 61 times 2 squared minus 168 times 2. And then it'll be minus the same function with 0 plugged in, which would just be 0. So we'll have this part. 2 to the 4th is 16. 2 cubed is 8. 2 squared is 4. And then we just have 2. So 1/4 times 16 is 4. Minus 7 times 8, so minus 56. Plus 61 times 4, so plus 244. Minus 168 times 2, so minus 336. So this is negative 144. So it makes sense that it's negative because this is area below the curve. So that's why we take the absolute value to get that the area is 144 for this section. So that's 144. For our next section, we'll plug in 7, and then we'll minus that same thing when 2 is plugged in. So we have plus the absolute value. So we have 1/4 times 7 to the 4th minus 7 times 7 cubed plus 61 times 7 squared minus 168 times 7. And then we'll have all of that minus what we get when we plug in 2. So over here, we already plugged in 2, and we know that that's going to give us negative 144. So it'll be minus negative 144. 7 to the 4th is 2,401. 7 cubed is 343, and 7 squared is 49. So we have plus the absolute value of 1/4 times 2401 is 600.25. Negative 7 times 343 is negative 2401. Then we have plus 61 times 49, which is 2,989, minus 168 times 7, which is 1,176. So we have all of that minus negative 144, so it'll be plus 144. So this will be plus the absolute value of 12.25 plus 144, which gives us a positive 156.25. So the area of this middle section is 156.25. Finally, we'll have the area of our last section, which will be when we plug in 10 minus when we plug in 7. So it'll be plus the absolute value of 1/4, 10 to the 4th, minus 7 times 10 cubed, plus 61 times 10 squared, minus 168 times 10. So it'll be all of that minus when we plug in 7. And we found out when we plug in 7 that it would be 12.25. So it'll be minus 12.25. And that would also be written here as well. So 10 to the 4th is 10,000. 10 cubed is 1,000. 10 squared is 100. And then we have 10. So this is plus the absolute value of 1/4 of 10,000, which is 2,500, minus 7 times 1,000, so negative 7,000, plus 61 times 100, so plus 6,100, minus 168 times 10, and then minus 12.25. So this is negative 92.25. So the absolute value of that is going to be positive 92.25. So this means that the area here till 10 is 92.25. So the total area from 0 to 10 is 392.5 units squared. So in summary, to find the solution to a definite integral, you'll take the integral and evaluate it at the final point, then subtract the integral evaluated at the initial point, like shown here. And some integrals cannot be solved without technology. To find the area between a curve y equals f of x and the x-axis, you'll find when f of x is greater than 0, and then split the interval into intervals where f of x is positive and separate intervals where f of x is negative. And then you'll find the integral for each separate area and add the absolute value of all of them together for the total area. And to find the area between two curves, you'll find when the functions are equal to each other to find your limits of integration, and take the integral from the first intersection point to the next intersection point of the function on top minus the function on bottom. That's all for this video. Thank you for watching.